All right, welcome to our Beginners Academy Zoom meeting. I'm Greg, N4KGL. I'm happy to bring to you a talk by Wesley Effner, KN4NPH from Panama City, Florida. And he's going to share his experiences with a rig expert. I believe it's the AA35. So with that, we'll turn it over to you, Wes.
An antenna analyzer. My particular antenna analyzer, my first antenna analyzer was the AA30. And when the VNAs came out, I said, oh, I got to get one of those. So I sold my AA30 and bought a network analyzer. A big mistake, big mistake. The network analyzers, the mini 60 and all those other ones, the VNAs, are more labor intensive. In other words, you set all the parameters first. Whereas with the rig expert analyzers and the MFJ analyzers, you basically push a button or flip a switch. So I regret selling that AA30. I've got the AA35 as its replacement, and the VNA is sitting on the shelf gathering dust. But an analyzer is basically a way of analyzing how your antenna appears to your radio. Okay, it goes by various names. You've got sometimes it's called a network analyzer, sometimes it's called an SWR bridge, noise bridge, RX bridge, RF bridge. It's all the same thing. It's just a different way of naming it. Now we're going to talk about what it does, and then of course I'm going to give you a demonstration. I've got two antennas queued up. And I'll show you how I tune those antennas, or at least check to see where they're resonant and what I can do or what I can't do to bring them into resonant if they're not, or change bands, things like that. So without further ado, let's talk about what it is. A network, let me call it an antenna analyzer. An antenna analyzer is just basically a signal generator, a very low power signal generator. I scoped mine on my oscilloscope, and I'm putting out about 1.5 volts peak to peak, and that translates to about 6 milliwatts, which is more than enough to tickle, virtually any antenna. You don't want a lot of power on your antenna because you're testing. You don't want to be sending out a carrier on any one particular band that you don't want others to receive, and that's the idea of the low power signal out of the analyzer, and it's a square wave, so it's rich in harmonics. And mine is in the range of 1 actually to 35. The model number designates the range, so I can sweep below 1 megahertz. I think it's 60 kilohertz, or 60 kilohertz up to 35.5 megahertz. This will actually reach those frequencies, but they don't advertise it. They say it's from 160 to 10 meters. And what they do is they use the most basic type of bridge detector, and that's the resistive bridge detector, because it's low component count and it's accurate, and it doesn't require a lot of support electronics, if you will. And of course, you got to have a microprocessor to analyze the data, crunch the numbers, and do the heavy lifting. And some of the things that a typical antenna analyzer can do is, of course, basically is calculate impedance, measure your SWR, indicate your resonant frequency, return loss, phase. You can actually use it to measure inductors and capacitors, but I wouldn't personally I don't do that because I've got my own LC meter. And all this is tied together with a graphical display and a keypad so that you can make the thing work. And that's what it is. Basically simple. And if you think about it, you've got one already and you didn't even know it. And that's your radio. Your radio is your signal source. And if you've got an external SWR meter or power meter or a built-in power meter and SWR meter in your radio, you've got the makings of a crude antenna analyzer. However, your radio and your antenna analyzer or your dummy load or your tuner wasn't meant to be used like that, but it could be if you had to. Obviously, you don't want to radiate a lot of power into your antenna while you're testing, so it's not really a good idea to do it. But basically, you've got everything that an antenna analyzer is already sitting on your desk. And of course, when you add up all those items, you get your analyzer, and basically it just attaches to your antenna. How does it work? Well, antenna analyzer, because it's more automated than a VNA where you have to set up the various parameters, basically you're pushing buttons if you know which buttons to push. But first thing you're going to do is you're going to apply a known frequency, or you're going to sweep a band of frequencies. And it can be any particular ham band or any particular group of frequencies in the ham band. Then you're going to measure the forward and reflected power using that resistive bridge, and then you're going to calculate and plot on that little LCD screen. You're going to plot where those points are on that screen. And on other screens, while you're watching the resonant frequency screen, you're going to be calculating SWR and return loss, impedance, phase angle, all kinds of different things, but you won't necessarily see those on that one screen. And then you're going to repeat everything all over again until you've swept from the left side of your display to the right side of your display, or the range of your frequencies that you keyed in. And that's basically it. In my demonstration, I'll show you what the menu does, and they're typically, they're pretty standard throughout the rig experts. MFJ, I'm not familiar with at all, so I can't tell you how the menus match up against the rig expert or vice versa. I'll talk about some of the functions that I use to check and test an antenna. And then, like I said, I'm going to tickle a couple of antennas here. I've got a 20-meter V dipole. I'm using MFJ loaded whips in a V configuration on a fence pole about 20 feet up in the air. I set this up about 6 months ago, and I haven't really done anything with it. It's drifted. The frequency, the resonant frequency has changed slightly, but not enough to affect having to use a tuner. But I'll show you that, and I'll show you how you can move the resonant point above and below where the antenna is normally resonant. And then I'll discuss some of the various readings. Again, I'm not strong on math. I'll tell you what I know and confuse you as much as I can, and then you can figure it out later, because the internet is your friend. And then we'll talk about any questions, and I'll try to answer any questions that you have.
Awesome.
All right, this typically when you turn the AA35 on, this is the screen you'll see. It's got 4 menus on this screen: the SWR chart, the RX chart, the SWR meter, all parameters, which I'll discuss very briefly because some of the stuff, it's beyond what a normal ham would use unless you're designing antennas or doing some major renovations to your antenna. What I like to do basically is set my range. I mentioned that you could set a specific frequency, or you can sweep a group of frequencies. And the AA35 allows you to do that with the simple push of a button. You won't see me push the button, but you might hear the click and you'll see the result. So this is a 35 megahertz bandwidth or band frequency range on the AA35. So I'm going to set it to the middle, and that's what, 17.5. And then I'm going to sweep 17. I'm sorry. Try that again. I'm going to sweep 17.5 on either side. So basically what I'm doing is I'm sweeping the entire range of the analyzer. And then when I go to SWR chart, you'll see that on the low end, I've got my two, whatever those lower frequencies are, but let's just say from 160 on the left to 10 meters on the right. Okay. 160 is down here and 10 meters is up here. And I've got my, which antenna have I got on there now? Right now I've got the 20-meter dipole on there, and I'm going to sweep it. And I say what I'm going to do is I'm going to sweep from the low end to the high end, and I'm going to stop along the way. There's 100 points that it stops along the way, and it measures the SWR, it calculates the SWR, and plots it on that little screen. So this is what you'll see. See a lot of bumps and squiggles. Well, if I was hooking up to an antenna that I didn't know where the resonance point was, I would typically pick the biggest dip. Okay. And in my case, I know, well, it should be, okay, let me spread that out a little bit.
Hey, Wes.
As I moved my center frequency, you'll see that the center frequency is indicated here. Right now I'm at 14,350, and I'm looking at the spectrum, if you will, 5 megahertz either side of that. Okay, so I'm looking at from looks like 9 megahertz up to probably 19 megahertz, and 20 meters is right in the middle. So I can expand that out, and when I do, you'll see the sweep range decrease. So I'm expanding what I'm looking at into a larger area, and I can move it to the center of my screen. I don't know if you can see this line, this thin line here, and there's a caret above it. That's where my center frequency is.
We can see it very well. I
Okay.
can.
If you go to speaker view, you get a blown up picture, everybody.
Say again?
Go to speaker view.
Speaker view.
Not
Well,
you,
that's for everybody else.
for everyone else. If you go to view and go to speaker view, then you can see Wes's screen bigger when he's speaking.
Wow.
Oh, yeah,
Oh, there it is.
right, okay, I'll do that. Oh, yeah, that works good.
Wait a minute.
Did I do something?
No, you're good.
No, it's for us, not
Yeah,
for you.
well,
You just-
okay, I've
just
got
keep
it
on-
full screen. I got full screen on here now. I didn't
Yeah.
realize that was up there.
Yeah.
Okay.
Keep on trucking, Wes.
Okay. The darkened area that you see is the upper and lower limit of the 20-meter band. So it tells me, it doesn't tell me the frequencies of it, but it tells me where graphically it would normally, where it is. So I can see that my center line, my center frequency, right now it's 14,170 megahertz. Okay. And I'm sweeping 500 kilohertz on either side of that. And you can see that my sweep started in the left side, and it swept somewhere to the right, but then I stopped. So let me re-sweep it again. Okay. And where that greatest dip is, that's where I'm resonant at. And if you look down at the bottom, you'll see it says minimum 1.45 at 14,220. That's the SWR. That's the lowest SWR it calculated, and the frequency that it calculated it at, even though I'm currently set at 14,170. Okay. So if I wanted to move, if you look at that, you can see that from the left side to the right side, the SWR through the entire 20-meter band is less than 2-to-1. So I should be happy with that. And I am happy. I'm happy that it didn't change because the antenna, is out in the elements and I didn't really protect it that well. So now I've verified where my resonant frequency is, and it's well within my personal limit for an SWR of less than 2.
The big advantage of this type of device is that it's easier to use than a nano VNA.
I think that's what it boils down to. Yeah, I mean, the nano VNA is, I got one going right here if you want to see it. Well, you've used one, I guess, but for those who haven't, you need powerful reading glasses for this little puppy. But it does much the same stuff. Now, while we're waiting for Wes to struggle there, I got a tablet running here. I don't know if this is going to work or not. Hang on. There we go. This is Android. So they make a little application here. You need an OTG cable and hook up to there. Now what's happening? Oh, we're picking up someone else's picture. Anyways, are you guys seeing my screen here?
Yeah, we see it.
Okay, and I'll start the program.
Like Jim's rig expert left the meeting.
Great.
Yeah, I brought in my new LCR.
I can hear you and you
Um,
can't hear
somebody
me. And
did
when
that.
I can't hear you, you can hear me.
There you go.
I can hear you,
There you
Wes.
go. You're on now. Go ahead.
Go ahead, Wes.
Oh, we got you.
Yeah.
now, Wes.
Hey, I'm back. I'm back until my battery goes dead. Okay. You can see that the SWR is 1.49. If I quit out of that and I come down here, when I really regret this, to this all parameters thing, click on that and have it look at all the data that's been gathering from my antenna. You can see that the SWR is still 1.49. The impedance is 54 ohms. That's pretty close to 50 ohms. Right? The resistance is 50 ohms. 20 ohms of that is inductance and or capacitive reactance. And the return loss, let me tell you what I know about return loss. Return loss is related to SWR. That SWR is a unitless measurement that references an ideal system that we assign a number of 1 to. We assign 1 to a perfect SWR, and SWR is related to that. Well, return loss is also related to SWR, but when you say return loss, you would think that smaller numbers would be better and larger numbers would be worse, but it's not that way. It's the opposite. It's not logarithmically inverted or directly inversely proportional is what I want to say. But you want a high return loss number. Return loss is measured in dBm. Again, where SWR is a unitless type of measurement. But there are
in dB, I think.
Yeah, dBm.
dBm is
dB.
relative to a milliwatt is dB.
Yeah, dB. So there's formulas that on the internet that you can look up what the SWR equivalent to in return loss. I can tell you that at 2-to-1 SWR, the return loss is 9.5. Okay, so that's probably, for me, that would be my minimum return loss, 9.5. Anything greater than 9.5 makes me even happier. And at 3-to-1, the return loss drops to 6. So you can see that as the SWR goes up, return loss goes down. You want a high return loss number. Okay, let's get out of that. Let's switch over to my other antenna. I'm not going to tell you what that is. I'm gonna let you guess it. Again, I'm gonna set my full range, 17.5, and I'm gonna sweep 17.5. So I'm gonna sweep the full HF band. Hello. Okay, if you look toward the left side of the screen, you can see that I've got a really deep resonant point. I've got a couple of them on the low end, on the low frequency end of the spectrum. So let me move down there. I can do that first over. Remember that the line down the middle of that screen with the caret on top is my center frequency. So right now I'm at 6650, and I'm going to expand that out so I can see those numbers a little bit better. And I'm going to go up to the 40 meter band, expand that out a little bit more, sweep it one more time, and you can see that the SWR on the left side in the 40 meter band is 2.5, and it climbs up to more than 3. All right. So ideally, I normally wouldn't use this antenna on that band, but I've got the magic of a antenna tuner, which doesn't really tune the antenna. It just makes the radio happy. So I'm going to switch in my antenna tuner, and I'm going to exit out of here. I'm going to go down to SWR meter. The way to do that is because the SWR meter responds faster than the sweep does, and it's easier to tune or to adjust an antenna tuner to move the SWR than it is to move the sweep. So I'm measuring my SWR now on my antenna, and it's 35, obviously much too high. So you're going to hear me adjust my antenna tuner until I come into a range that I think I can drop it down, and then I'm going to slowly adjust. Okay. Now, sometimes on on this particular tuner, there's more than one inductor tap that will allow me to adjust an antenna or tune an antenna down below the into the safe range. So I'm going to try that. Nope. Whoops. No, that's 20 miles.
Yeah, that 1.6 is pretty good. It
Well,
got down there, yeah.
Yeah, it's just touching the knob changes. I'm adding capacitance to the system. I'm going to stick with 1.89.
Okay.
Okay, so I out of that. I go back to the sweep. And remember, this is my original sweep. All right, this was without the antenna, without the tuner, and now I'm going to resweep. Now you see the dip. So I'm going to band it out, so it's almost full screen. Sweep it in. And now you can see that my resonant point is almost right in the middle of the band, because that's where I told it to set my SWR meter to, so that I could adjust it. Okay. Now, if you look to the left, you'll see that the SWR at the low end of the band is still above 3, but in the middle it's at 2, and again on the high end of the band it's back up to 3. Whereas before, I didn't have any portion of that band I could use the radio safely on. So that's how you do that. Let's go back to, oh, another feature of the AA35 is if I don't want to set a range of frequencies, I can simply push a button combination and choose the band that I want to look at. Okay. Now, if I remember correctly, 80 meters was a good band, or it was close. So now when I go into my SWR screen, I can see the entire 100, what is that? 80 meter band. So I can sweep it. Whoops. Out. So I got something, but I don't have much. If I expand this out or I shrink the band, I shrink the overall band, I get more frequencies. I can see where I have a dip. And you can see I had that major dip to the right, and that was the 40 meter dip. And now I've got a dip also to the left, which I can use for 80 meters. And I'm going to use that. So I'm going to move my display over closer to that dip. And then I'm going to go to my SWR, check it. But I want it in the middle of the, and I'm not that familiar with that band. So I'm going to shoot for a 3750. You'll see up here that I've set my center frequency to 3750. And right there, my SWR is 4.8.
Yep. Are you still on the tuner, or did you take it out?
I took the tuner out initially.
Okay. All right.
Now the tuner's back in, and you can see that obviously the value I've got set in there from the 40 meter doesn't work with the 80 meter band. So I have to adjust. I see the SWR drop. Now, because I'm up in frequency, I'm low in frequency, it's going to be sharper drop, and there might only be one or two bands that I can actually use. There we go. It's very sharp tuning because as you go down in frequency, of course, the bandwidth of your antenna can be significant, can be less, much less than a higher frequency. Okay, 0.28. Go back. This was my original sweep on 80 meters. Big difference. Let me expand that out. Now at the low end, I'm still above, well above 3, and at the high end, I'm well above 3. But in the middle, or if that's where I want to, that's where I want to operate, then I adjust it down to less than 1.5, and I can shift that resonant point with my tuner by going to the SWR, setting the frequency that I want to operate on, and then adjusting my my tuner to lower the SWR to the value I can live with. Okay, that's basically it. That's how it works.
Yeah. Well, that's awesome.
It is. It's handy. It's quick. And with the VNA, no bad things towards Chris. Too many buttons. I mean, geez, just too many buttons on that VNA. In fact, I've got a VNA. If you want to buy a VNA, I got one. I 3D printed a nice case for it. Yeah, I'll go cheap. Give me enough to take my wife out to dinner. Yeah, we'll call it even. Okay. That's all I've got to say about that.
All right.
Any questions? With the VNA, you've got the option of a Smith chart. Okay. Well, with the Rig Expert, you can save screenshots of various sweeps or a sweep, and then you can upload that to your PC, or I'm not sure if there's Android or Apple app for it, but there's an application on Windows called Ant Scope, and it will let you upload those sweeps, and you can analyze it in a bunch of other tests, which is quite convenient. So like if you're out in a rainstorm or it's going to start raining and you want to take some measurements, you can take those measurements, store them on the device, and bring the device in and upload those to AntScope, the application on your PC, and analyze what you got.
Cool. Is
So
that thing, what kind of water rating has that thing got, Wes? Like, is it, I don't think you can go underwater with it, but is it good for a rain shower or damp location when you're running it?
Yeah, I don't have any trouble. I have never tried to rain. I don't think, just like a Volkswagen. Volkswagen will definitely float, but it won't float indefinitely.
Yeah. Well, it looks a lot more robust than the VNA. I mean, look at that.
Oh,
It's
yeah,
got
yeah,
all the
yeah.
circuit board. I mean, you spit on that thing and it's dead.
No, mine's got a case, so it doesn't have that exposure like yours
Yeah.
does. But I'd never take my VNA out in the field. It's just more work than it's worth.
Yeah. Well, you
That's-
can on a sunny day, but that's about it.
Yeah. Again, that's why I turned around and bought another Rig Expert and kicked myself in the butt for selling the first one. Oh, one more thing too. The analyzer, it takes 2 AA batteries, but you can also use nickel metal hydride rechargeable batteries. And they tell you that in the owner's manual. Don't use regular lithium ion batteries because it's too high voltage, but you can use nickel metal hydride. So a friend of mine bought me a charger and 2 batteries for this, and now I don't have to worry about feeding it batteries, which is convenient. And that's about all I got to say.
Thank you, Wes.
Yeah, we appreciate it. It's well put together.
Yeah, yeah.
Well,
Except for the difficulty of seeing it and hearing about it.
well, we'll do a little editing and it will come out great.
Oh boy.
Thanks, Wes.
Hey, appreciate it.